Hello and welcome everyone to the third expert panel on our international conference topic, air quality. My name is April Mickley. I am the Executive Director of Future Problem Solving. And one of the best things, in my opinion, about our program are the students and the leadership of the students. And it was a little over a year ago that Talia reached out to me and posed the idea of a student advisory group. It was a well thought out plan, almost like an action plan, perhaps, where she laid out some ideas on how the student advisory group could strengthen our program. Obviously, their hard work has been a tremendous success. She has other leaders that she has worked with. They're here with us today, Toby and Brianne. And the three of them, along with others on the advisory group, have solicited some excellent speakers here on the topic to help us all learn a bit more and get ready for the international conference. Talia, I turn the session over to you, and I very much thank and appreciate our presenters.
Thank you so much, April, for that introduction. The Student Advisory Group is so excited to welcome our panelists and everyone in attendance today to this research panel for the international conference topic of air quality. One of our central goals as an advisory group is to enhance the research component of FPS. So this panel is a direct extension of that goal. Before we get going, I want to quickly talk about how this panel will operate and a few community guidelines to ensure this event runs as smoothly as possible. So first, this event is being recorded. We will be sharing the recording with all who registered for today's event to ensure that everyone is able to access this fantastic resource, even if they weren't able to be here today. Second, the chat feature should be used to discuss items related to the panel or to respond to questions posed by the moderators. Please refrain from sending repeated messages or discussing items not relevant to the panel. And finally, the Q&A feature should be used to ask follow-up or new questions for the speakers. The moderators, Toby and Brianne, will address as many of these questions as possible. So moving on to the next slide. Today's panel will focus on the international conference topic of air quality. We place a particular emphasis on the research question of how will the quality of air, which is a globally shared resource essential for human health and prosperity, impact us in the future. So our fantastic panelists that have joined us today will allow us to further explore this question. So with that, I'll pass it over to our amazing moderators, Brianne and Toby, to introduce our speakers and start asking questions.
So our first panelist is Dr. Angela Dickens, and Dr. Dickens is the data scientist at Lake Michigan University, Lake Michigan Air Directors Consortium, a 6-state regional planning organization. Her work includes air quality data analysis, and her research interests include the chemistry of the formation of air pollution, the impacts of transport of air pollution, and the application of science to environmental policymaking. She has previously worked as an air policy analyst with the Wisconsin Department of Natural Resources with the EPA and as a chemistry professor at Mount Holyoke College. Ms. Gail Good is the Air Management Program Director at Wisconsin's Department of Natural Resources. She is responsible for air quality and oversees all aspects of air permitting, compliance, monitoring, and planning in Wisconsin. Her program monitors statewide air quality, and she has supported projects focused on refurbishing and donating monitoring equipment and computer monitors from air monitoring stations. As a member of the Federal Clean Air Act Advisory Committee, she provides environmental regulation recommendations to the EPA. She is also a member of the National Association of Clean Air Agencies and the EPA U.S. Governmental Advisory Committee to the United States Representative to the North American Commission for Environmental Cooperation. And Dr. Vijay Limaye is a climate and health scientist with the Natural Resource Defense Council and a professor in the University of Wisconsin-Madison's Department of Population Health Sciences. His research interests are broadly focused on addressing international environmental health challenges with an emphasis on the public health burdens of air pollution and extreme heat. Prior to joining NRDC, he worked as a U.S. Environmental Protection Agency scientist focusing on the Clean Air Act regulatory implementation, air quality monitoring policy, and health risk communication. Dr. Limaye is a Wisconsin FPS alumnus, and we really appreciate all our panelists for joining us today.
Yeah, thank you all so much for being here. Miss Good, Dr. Dickens, and Dr. Is it Limaye? Am I pronouncing that right? Okay, cool. So, excuse me. Unless you guys have anything else to add, I think we'll just jump straight into it. Thank you all so much for being here. We really appreciate all of you. And yeah, we have a list of questions. Anyone who would like to answer it can, and then we'll see if anyone else has anything else to add on after that. So our first question is kind of more general. What would you predict that global air quality might look like 20 to 30 years down the line? And what like long-term effects specifically do you think we'll start seeing at that point? And whoever would like to start.
I'm happy to start. This is Gail. This is a great question. It's really important to know that 50, 40, 30 years ago, our air quality, especially in the US, was much worse than it is now. And things like particulate, ground level ozone, sulfur dioxide we just see those in much less concentrations now than we did some time ago. But warming temperatures are causing some new issues that we have to contend with. Things like greater instances of wildfire smoke and more particulate, and higher concentrations of ground level ozone. So, and globally, there are really heavy users still of fossil fuels. And so while Wisconsin and other parts of this country have been reducing that use, and there's still some use of that. It's far better controlled than across the rest of the world. So 20 to 30 years from now, tough to know what we might see. I hope we'll continue to see, continuing better and better air quality here in our country. But like I said, some of the global temperature issues that we're seeing now are certainly causing us to have to contend with some new issues. Maybe I'll see if any of my other colleagues here want to take a shot at that question.
I mean, I think you hit the main things I kind of think about when I think about future air quality, at least in terms of the major pollutants, is you get more ground level ozone with hotter temperatures. And so that's something that a lot of different studies are projecting, is that ozone pollution is going to get worse. Ground level ozone pollution, the part that's bad for your health, is going to get worse. And then the other big thing, as we saw last summer in most of the country, is the smoke and the Western US has been seeing for a decade or so, is that smoke and transported smoke from wildfires is going to keep being an issue. And we don't know how often, we don't know how bad it's going to be. We're both Gail and I are in Wisconsin. I think Vijay, you in Chicago, I believe. So yeah, we're all kind of regional, like close to each other. And it was a wild summer last year. And so we don't know how often that's going to happen, but it's pretty clear it's going to happen more often. And it does sort of, we've had this great improvements over the last few decades, and we're seeing kind of the smoke transported smoke kind of starting to wash some of that out. So those to me are the big issues.
Yeah, I agree. It's great to be with you all as an FPS alum. Back in 1997, I was getting ready for the International Bowl. So I'm really happy to be with this group. That was back in 7th grade. Yeah, I totally agree with the points my esteemed panelists have made. I think one other point I'd make, which is not really about air quality, but more about the health risks of that, is that we do in the US and in many countries have population aging happening right now. So when we look into the future, right now we have maybe about 58 million Americans who are 65 or older by the middle of the century. So in another 26 years or so, we're going to see that 58 jump to about 82 million. That's a 47% increase. We know that younger folks and older folks are especially vulnerable to air pollution. So even if things were to stay the same, which they won't, probably the health burden would be larger than it's right now. And as you've heard from my other panelists, both ozone and smoke issues are expected to worsen pretty significantly in the future. So that's a big worry for me as a public health scientist.
Thank you so much, all of you. I think we'll probably circle back to that at some point, but I wanted to go back to what you said about air quality being actually better in the past, or excuse me, worse in the past like 30, 40, 50 years, and then it's better now. What actions did the scientific community, or I guess did we in general take to get from worse air quality to where we are now? And can we maybe learn something from what we've done in the past to continue moving forward?
Yeah, absolutely. What I see as a major contributor to better air quality was the Clean Air Act over 50 years ago. Federal legislation that has been amended several times that we use to, it's kind of the regulations for the community that emits air pollution to follow. I see that as hugely impactful and still continuing to have a tremendous impact on our air quality as we continue to implement the Federal Clean Air Act. The act really promoted the use of technology to solve some of our air quality problems. And I think we're still learning a lot about that.
Does anyone else have anything they'd want to add to that?
That was a great answer from Gail. I'd say as someone who was at EPA working on the Clean Air Act implementation, yeah, it is this world-leading example of how to combine science and the law to understand air quality conditions across the country, to use our understanding from health science, especially to understand what that air pollution does to us, and then use the law to enforce limits on air pollution. So we have health-based national, what are called standards. You can think of them as health-based limits on how much air pollution is allowed to be in the ambient air, and we can legally enforce those, and we have permits and all sorts of ways to try to hold polluters accountable. So I totally agree. This has been probably the most effective environmental and public health law that this country has ever seen. And it continues to pay dividends. Just, this year we had strengthening of some of those limits. So this is kind of an ongoing, living, breathing law that is not just something that was, put on paper in 1970 and updated in 1990, but continues to make all of us live longer and healthier lives.
Yeah, I'd agree with all that. I think it's mostly Clean Air Act and regulations. We have benefited also from some changes in the economics of coal and natural gas, where natural gas has gotten really cheap, and it's less polluting in terms of the criteria pollutants. It does still have greenhouse gas emissions and probably more fugitive greenhouse gas emissions than we realize, but the air quality has also benefited from that as well. But the Clean Air Act, I would say, gets most of the credit. And it's something too, looking forward, they're definitely, it's still in place and it's still going to continue to give a lot. We're definitely going to still benefit from it going forward. I think it's also the point where we had Clean Air Act amendments in 1990 because we learned a lot about both the science and the how to like possible policy mechanisms, and that sort of really made a big impact. I think we're at the point where we could use another kind of reevaluation of the Clean Air Act, another set of amendments, but I don't think it's going to happen. I don't think we want that to happen with Congress the way it is right now. So sort of the point where it'd be great if we had a more rational Congress right now.
That makes sense. Could one of you maybe just give a quick summary of the Clean Air Act and kind of more the specifics of what it exactly does? I don't know if that's even something feasible because I'm not super familiar with it. I don't know. Is it really complicated? It's not really something we can get into?
It's enormous. It's thousands, I don't know the act itself. I actually don't know how long it is, but it's enormous. It's immensely complicated. Some of the main components relative to ambient air quality, ambient meaning environmental air quality, are these national ambient air quality standards. So the EPA set and has continued to update every so often, supposed to be every 5 years, in practice it's less frequent. A set of standards for 6 what are called criteria air pollutants, like ozone, particulate matter, sulfur dioxide, nitrogen dioxide, lead, carbon monoxide. So that's kind of one of the core components of it. And they set a level in the atmosphere you're not supposed to go above. And if you do go above that, then there are sort of consequences and some kind of sticks involved there. And that's kind of one of the core components, but it's enormously complex.
That makes sense.
Yeah, I might just add that through the Clean Air Act, the federal government distributes money to states and localities to monitor the air quality. So the great folks at Wisconsin DNR are in charge of Wisconsin's air quality monitoring network, for example. And it's like really the gold standard of environmental monitoring is what's happening across the US in terms of air quality. So we have a lot to thank, and it's kind of unsung behind the scenes work, but it makes all of this possible.
And the monitoring is really foundational to the rest of the air quality work that happens, like in a state like Wisconsin. And Vijay did a great job at explaining some of those things, like the permitting that is done to explain to sources what regulations they need to comply with, the compliance and possibly enforcement that we can do with those sources, either to help them comply or, in some cases to enforce the law upon them when they're not complying. And then, of course, all of this takes a lot of planning and a lot of commitment on the part of the air agencies and others to make it all work.
Wow, that's really interesting. I don't know if this is maybe a little bit outside of your expertise, but do you guys know of any other countries that have similar acts or laws to the ones that we have in the US, and like how they would compare to this act that we've been talking about?
I can say a bit. I'd say I do quite a bit of work internationally. I'll say that the World Health Organization, for example, not a government, but it helps to track all the health science around air pollution and helps us to understand what the harms are of exposure. And many governments, especially in the global north, have taken the example of the Clean Air Act, not carbon copied, but the similar approach of doing monitoring, compliance and enforcement, policy mechanisms, this kind of suite of tools to try to clean up the air. I do a lot of work in India as well. India has its own national standards on air pollution. Many of you may know that India is home to some of the most polluted cities on the planet. And part of that is economics. Part of it is also the challenge of enforcement that Gail just mentioned. We don't have a strong legal enforcement and compliance mechanism. So sometimes it's not about what's on paper necessarily, but what's happening on the ground with what that paper says should be done.
That makes sense. And kind of in a similar vein, would you guys be able to explain kind of what the research to actual policy, like what that pipeline looks like? How does research turn into legislation that then is being enacted and enforced?
I can start with that. There's a lot of different places where science research comes into the process. So when I was at EPA, I was doing a AAAS Science and Technology Policy Fellowship. And that's sort of one way. It's a program that brings PhD scientists into the government to work in federal government in different aspects. So it's not just air quality, it's across, people are doing, well, they're now doing AI and they're doing, health science and other things. But there are a lot of, I guess, yeah, Vijay was at EPA. There's a lot of scientists in the government working. Some of them are doing research, like EPA has an Office of Research and Development that does some kind of primary research, always with a kind of an eye towards the policy applications. So it's not, some of it is very basic research, but it is sort of in a policy context. There's, people in the States who do that. When I was at Wisconsin, I was involved in some research studies, working with academics, and there's academic researchers who are doing on policy, some of it's policy relevant. And so there's a great quote. I meant to look up who said this quote. I feel like it might be Victor Hugo. It doesn't completely make sense, but it's a quote saying, science has the first word in everything and the last word in nothing. So it's like you want to have science in there informing what you do for decision making, but it doesn't tell you exactly what to do. Like you want to know, for example, what pollutant is controlling your ozone concentration, or what emissions are controlling your ozone concentrations, or what's controlling the particulate matter concentrations. But that doesn't tell you what you do about it. You need the policy, you need the policy levers, you need to know how do you actually make a policy that's acceptable to the public and that they can actually comply. So it informs it, and it provides essential answers to help you know what might actually work in the atmosphere. But it doesn't tell you exactly what you do policy-wise or how to do it.
That makes sense. So they have to like work together pretty much to
Definitely. Yeah. Which is
Anything-
very frustrating to me as a scientist going into government, because I was sort of thinking they just need to know the science. And that's not the case. It's you need the science, but you need to be working with people who understand the policy and the law and like public perception and all of that.
Yeah, that makes sense. Would either Miss Gail or Dr. Limaye have anything else to add?
I think Angie did a great job responding to that question. And I would say the science and the work that we do in air quality continues. We're continuously learning more about the chemistry of pollution, or what contributes the most to some of our air quality issues. And so that, as science continues to evolve, I think how science is utilized in air quality work is going to continue to evolve. And Angie's absolutely right. The science informs, and then there is work to be done to understand what the law can do and what is economically and technologically feasible as well.
Yep, I love what Angie and Gail said. From the health science perspective, it can get pretty tricky to try to understand which pollutant is causing which health outcome. If you can imagine, if we have a lot of air pollution and we're trying to understand what lower levels of air pollution mean for health, then it can be kind of tricky because we don't have many spots or many people living in those spots, right? So just like Gail mentioned, all of the science that is continuously improving, especially on understanding what pollution is, where it's coming from, the same goes for health effects. We're learning more and more every day about how dangerous air pollution is, even as we have made so many strides, as Gail mentioned in the first answer. It doesn't appear that there's a safe level, at least not one that health scientists are confident about. So science is required to be used by the Clean Air Act. It's the best available science that the agency has to rely on. And that's a little bit up for debate sometimes, right? There's no arbiter of what the best available science is necessarily. So it requires a lot of people looking very carefully at these studies and understanding if they are valid, right? There's thousands of studies on air pollution and they're not all conducted in the same way. So there can be a lot of work and challenge in translating and synthesizing that science.
It's really interesting. Thank you. I think kind of one more question in the policy area before we move on to something different. Are there any like regulatory actions that are currently taking place, or anything that's like currently working its way through the system that you know of that you could kind of share with us?
Yeah, I'd be happy to. Actually, EPA is really busy right now, doing a lot of new rulemaking. Just in the last several months, we've seen rules that impact motor vehicles and emissions from them. We're seeing rules that apply to power plants, and especially in the way that they emit greenhouse gases. We're seeing rules about mercury and air toxics, and also some rules about how permitting is done. So yeah, very busy EPA, a lot of regulation, and a lot of it around climate change and greenhouse gases right now.
Cool. Anything else that? Oh yeah, go ahead.
Well, I'll say, so one of the big things in the air quality world, I mean, besides all the climate related things, is they came up with a new particulate matter standard, finalized published in, February anyways. And that's a big deal. That's, they lowered it quite low, quite a bit lower than it was. And so that's something all the states and everyone's trying to figure out how to manage this. How do we actually, at this point in time, lower particulate matter that much, especially when there's smoke adding to it?
That's a great one, Angie. That just went into effect May 6th, so very recent.
Yeah, I'll just add, so EPA, for everybody out there, is the U.S. Environmental Protection Agency. So it's the federal agency charged with protecting human health and the environment. And it was established in, I think, 1970, I want to say. One other thing that's happening right now is, just as you heard, the national limits for particulate matter, or soot, were tightened. Right now, one issue I'm working on that's very active is the EPA is considering whether or not to tighten the same limits around ozone pollution, that pollutant that you heard about in our first answer. EPA right now is saying we don't have enough clarity on the science. We want to take another look at the science. They're asking their technical experts to do that. And so that's a very active area. You heard that it's going to be a priority, definitely, for this country and the world, really, in the future. And that's an active area under investigation right now.
One other area that the EPA has been the EPA under Biden has been very active at is environmental justice. So trying to look at the impacts of, basically all the policies on the disparate impacts in different populations. So is it disproportionately impacting underprivileged communities? So that's another big area that is happening right now.
Oh yeah, that's another interesting angle to look at it. Very cool, thank you. So I think we'll move on from the policy for now and kind of talk more about the specifics. Like, what are some of the ways that you see poor air quality affecting people's everyday lives? Some of the health effects or anything else that you might see?
When thinking about this question, what really stood out to me, and Angie mentioned it a little bit earlier, was the Canadian wildfire smoke impacts that were especially prevalent last summer. And, every day while that was really going on, we were receiving phone calls. Can I ride my bike today? Should I take a jog today? Can my kids go outside and play soccer today? And, we at the Department of Natural Resources here, we learned a lot about how to communicate information really quickly, because this was impacting people's everyday lives and the things that they enjoyed. And even in some cases, we were getting phone calls, should I do my job outside today? For folks who work outside. So very, very impactful event that happened. And just that was obviously on a larger and more direct scale there with the extreme wildfire smoke impacts that we were seeing. But those impacts are really happening all of the time. And we are, informing people daily about their air quality so they can make decisions about how they spend their time outdoors, especially.
Yeah, I'll just add that some air pollution you can't see, right? And in fact, it's the air pollution you can't see that's especially dangerous for you, because it can penetrate past our kind of natural defense mechanisms. We cough, we sneeze, we swallow some of these bigger particles, but microscopic PM 2.5s, we're talking about 2.5 microns, like 1/30th the diameter of a strand of human hair. So you can't see it with your eyes. It's getting deep into your lungs if you breathe it in and enters your bloodstream. From there, it's able to travel to nearly every organ system in the body. Our health science, which there's tons of, shows that these fine particles are linked to all sorts of terrible health consequences, including heart disease, so hardening of the arteries. People don't realize that a top contributor can be air pollution exposure. Stroke risk, neurological dysfunction, lung cancer, chronic obstructive pulmonary disease, even something like diabetes, metabolic disorders are probably linked to air pollution. And so, I think it's already taking a big toll on people across the country. As much as we've made progress, we've got a lot more to do, especially as our health science improves and we understand more what's happening on the ground and happening to people who are exposed disproportionately high. We can't just think about the average level, right? We need to think about who's breathing in more than average. And typically, as Angela mentioned, that's communities of color, low-income communities, et cetera, et cetera. Maybe one thing I'll add as a health scientist too is that we also need to think about kind of combinations of pollutants that people are breathing in all at once, as well as different stressors that they feel in life. It might be that they're breathing in ozone pollution on an especially hot day, right? Because ozone formation is worse on hot days, and extreme heat is also bad for your health. And sometimes when you're hit with two things at once, the sum is greater than the parts in terms of your health risks. So there's a lot of worry when it comes to air quality, which is why I'm so glad you're focusing so much attention on this.
Would you have anything else to add, Dr. Dickens?
No, those are great answers, very thorough.
So I also wanted to touch in a similar vein, Dr. Dickens and Dr. Limaye, you both just now talked about this, that idea of environmental justice and like how it's affecting maybe lower income and disadvantaged people more. Can you kind of go a little bit more in depth on why it works that way and like the details on how it's impacting these people more than maybe less disenfortunate people?
Yeah, I mean, some of it's kind of the history of racism and economics in this country. Like they built highways. A lot of our highways are built through poor neighborhoods. They had less power to fight them and were viewed as kind of, an easier target. So they are easier place to grab land. So a lot of, poorer people, browner people live near highways, which are, pretty heavy sources of air quality. So a lot of it's that. I think it does combine, and Vijay can probably talk more about the combination with other stressors. If people have other health stressors, lower quality diet or other health issues they can't take care of as well, then they're maybe more susceptible to air quality issues. So I guess it's a slightly different question than what you asked, but a lot of it has to do with the kind of economic disparities and racial disparities.
No, yeah, that makes sense. Would anyone else have anything to add?
I think that's the key ingredient is that a lot of this is about economics. You can think about how property values, people want to live in cleaner places, right? Lower property values, which might be more affordable, tend to probably be closer to air pollution sources. We have big problems in this country when we talk about people's ability to access affordable health care, to understand at the very outset that these are issues when it comes to their health, and a lack of economic mobility to be in cleaner spots. So just like highways, a lot of power plants tend to be located near populations that are lower income or communities of color. It's not that these people choose to live in polluted areas, right? It's that we have, in some sense, like these sacrifice zones, right? Where we position some of our most polluting industry and the power that we all rely on in parts of cities where we have, lower political power to resist it. So it's a complex picture, but it's totally environmental racism.
Wow, that's really sad. It seems like everything's kind of against them, which is tragic. Would you have anything else to add, Ms. Good?
I think Angie and BJ did a great job with that. I will say that, there are health studies out there that we're starting to see that do show that there can be different response in different people as well. And so it's really important to continue to study that and understand how different people can react to air pollution so that we can just understand that better. There is a lot of work going on in the environmental justice world right now that is really impacting how regulatory agencies do their work, and that's good. And I really appreciate Angie and Vijay's responses on that.
I might just add for all of you, like an example of what Gail just mentioned, right? So it's like kind of this layering on of vulnerabilities. You can imagine if you live in a place where you can't access healthy food, fruits and vegetables, to eat a healthy diet, right? You may be at higher risk of chronic disease like high BMI, overweight, maybe heart disease. If you have a health condition already and you breathe in air pollution, you're at especially high risk for a severe outcome. So this is very tangible to all of us, right? And so I'm really glad that Gail mentioned that.
Yeah, thank you for sharing that. Sounds like it's a lot of factors all kind of compounding against them. Staying in that idea of the impact of poor air quality, how does air quality impact like the environment and the ecosystems, and like what are the environmental impacts, I guess?
This is not my focus area, but I'll just dive in and say that the Clean Air Act that does require human health-based limits on air pollution also includes what are called secondary limits, which are helping to basically deal with what's involved with this question, right? So the impact of air pollution on ecosystems and other, elements of life that we all depend on. So it's clear, for example, that ozone, and I'm thinking other air pollutants, are implicated in worse agricultural yields, for example. So our nutrition, you may not think about it, but our nutrition is very much tied to air quality conditions. We also know that, just like humans, many animals are also harmed by air pollution, although there is less research on that topic. So I would say that, there's disruption that we see not just in human health, but many other systems. And I will defer to my other panelists who probably know more.
That was good, Vijay. That's great. I would say also, we saw things kind of going back to like the 70s, 80s, even 90s, something called acid rain, where certain pollutants would be kind of transported and rained down on other parts of the country and really impact the health of things like lakes, streams, wetlands, and there's a lot of study and a lot of regulation that went in, environmental regulation that was put in place to address that issue because it was tremendously impactful.
I think we had
Vijay
over
mentioned
200
some of the
students sign up
impacts of
to
things like
attend.
agriculture and plants, and actually there's a whole area of study around how ozone, for example, impacts plants and what that looks like and what that means for the health of the plant. Great question.
Yeah, I don't have much to add to that either. It's not, I would have come up with the example that Vijay gave about ozone, fully leaf impact from ozone. It's not a lot I know, it's not an area I know a lot about. Like I do know there was a postdoc who's trying to get people interested in studying impacts of particulate matter pollution on birds. That those seem to be impacts, but I don't know that we really understand them very well.
That's interesting. Well, thanks for sharing, even though it's not like your expertise. Let's move on to maybe something a little more positive. What are some like new approaches or new technologies that are being used that are kind of like innovative solutions that we're using to address air pollution?
Well, maybe I'll just kick us off. I'm cognizant of talking too much though, so feel free to shut me up. The point was made earlier about the connection between energy economics and air quality conditions. And so we've talked a little bit about climate change, but one thing I'll say is that to deal with climate change, right, we need to transition away from polluting fossil fuels. So we're talking about burning things to derive energy for our homes, for our cars, for our airplanes, et cetera, right? Burning coal, oil, and gas each contribute to varying degrees to worsening air quality conditions. That's the bad news. The good news, and they also contribute to climate change, right? Carbon pollution, methane emissions, etc. The good news is when you switch to renewable, healthier energy sources like solar power, wind power, we end up reducing the emissions of health-harming air pollutants, right? We're not burning things in the vicinity of humans, but we're also not emitting climate changing pollution at the same time. So as much as there's plenty of technology to clean up coal-fired power plants and to try to reduce the amount of pollution coming out from a car's tailpipe, at this point in 2024, the most important thing we can do to reduce air quality problems globally and here in the US is to accelerate action towards renewable energy. So it's a win for the climate, it's a win for air quality, and it's a win for public health.
Yeah, I would absolutely agree with that. I think when it comes to some forms of pollution, as Gail said, we've made so much progress, and there's a real chance of a lot of that being countered by, basically you have the downward trend from all the hard work we've done, and then you have climate change leading to an upward trend to temperatures and smoke and everything. So I think, yeah, addressing climate change is really the #1 issue. And there are a lot of other things you can do more directly, but there's sort of this risk that if we don't address climate change, it's not going to matter as much. All this hard work is going to be kind of wiped out. So climate change for sure.
Yeah, I would completely agree. And, fortunately, under this presidential administration, we've seen a lot of resources going to addressing climate change, things that we see in the Inflation Reduction Act, like the Climate Pollution Reduction Grant programs that are providing billions of dollars. for state and local agencies to address climate pollution and to make an impact here in climate change. There are a lot of new technologies and things like that that can help, but that still in some ways rely on fossil fuels. And it really is about reducing our reliance on fossil fuels. It's going to make the difference.
Think about things kind of from a larger picture. We've also, in terms of kind of the more direct solutions to air quality issues, we've also like kind of done what we can do reasonably. Like we've done, and not even like not easy. None of it was easy, but we've kind of, you know, cars are so much cleaner than they were. Power plants are so much cleaner than they were. You know, industry is so much cleaner than they were. Like everything is. And so getting any more direct reduction there, it's possible, but it's going to be harder and harder and kind of increasingly hard. So that's sort of where you want to, I think, you know, going after climate change, or at least avoiding kind of anything that could push it the wrong direction, while we continue to, you know, try to work at that remaining bit, like kind of, you know, continuing to clean up the air, but trying to like avoid making things worse.
Yeah, and we know that as we address climate change and reduce emissions of greenhouse gases, we're going to see air quality co-benefits as well, meaning that other pollutants that we've been regulating, you know, for years, we're going to get some additional benefit and additional emissions reductions in those pollutants as well as we address climate change and greenhouse gas emissions.
Dr. Dickens, I want to go back to you. You were kind of talking about like maybe going the other direction, or like maybe doing something that ends up making it worse. Is that something that we've seen happen before, or am I misunderstanding what you were kind of talking about?
I was thinking more from climate change in the sense of the smoke, you know, the increased PM2.5 from smoke countering the reductions we've gotten over the decades, and same thing with ozone. Ozone's come down a lot. It's kind of actually both ozone and particulate matter are kind of flattening out a bit, and it's probably due, at least in part, was definitely due to fires in part, but also, you know, temperatures. If we get more ozone because of hotter temperatures, even though we reduce the emissions of nitrogen dioxide and VOCs, which are what forms ozone, but if it's all hotter, then you're going to get more ozone. So that's what I was talking about there.
That makes sense. Ms. Good, were you going to add something on to that, or?
Just to agree with Angie that we're, you know, in my part of the country in Wisconsin, you know, we are seeing, we've had ozone problems for a long time here in Wisconsin, and we did see those come down, ozone concentrations come down tremendously. And we did see a flattening out. We are actually starting to see a little bit of an increase in concentrations, likely the result of some of the wildfire smoke and impacts from that. So yeah, just to agree with Angie and confirm that we absolutely are seeing a flattening out or even a slight increase.
That makes sense. Well, thank you for sharing. In a similar vein, are there any new approaches or technologies specifically being used to monitor and measure air pollution that have recently been on the rise? And like, what are those? And well, yeah, what might that be?
Yeah, I'm really excited to talk about this one because there's been tremendous advances in regulatory monitoring equipment for a long time. We've gone to things like you know, equipment where you collected the pollution on some sort of filter or other media and had to have that analyzed, and that takes time, to what we see, you know, today, where, you know, we can really get continuous and you know, up to the minute information about what's going on with air quality, so that we can provide that to people and they can, you know, make very informed decisions about their activities and their health. What we're what we've been seeing for about a decade now, really on the rise though, is sensor monitoring. So regulatory monitors are very expensive, you know, $20,000, $30,000, $40,000 and more. And what we're seeing now is low-cost sensors that are easier to operate and can give information about air quality in a local area. Now, these monitors are not to the level of regulatory monitors. But like I said, they're easier to use and they're far more accessible. So people can use these kind of personal or sensor monitors and understand how their air quality in their area is changing, which can be really valuable. Some of these monitors even have, they can report to web pages so you can see across the country or, across where you live, who has these monitors and how they're responding and reporting. So that's been a pretty exciting advance, I think, to kind of put this technology into people's hands and to have them be able to use that and understand their kind of local air quality in a different way.
Yeah, I was definitely thinking about those sensors. The other thing I talk about is satellite data. So there's a lot of work to try to figure out, because even there, so we have, like, for the state of Wisconsin has, I think, 30 ozone air monitors, regulatory, the high cost, high quality ones Gail's talking about, and like 20 for particulate matter. And, that's kind of similar in other states. And then there are sensors, but there's also still a lot of spaces between any monitors. There's a lot of open space we can't monitor. And so there's a lot of work trying to figure out how to use satellite data. And it's tricky because satellites are up in space and they're looking down and they're measuring everything between the satellite and the ground. And so what we really care about for health is what's the ground level concentrations. But there's a lot of research going into trying to figure out, both how do you get the right algorithms and the right kind of calculations out of the satellite, but also just what kinds of information can you get out of them, and how can you answer questions that are relevant? And there's we've kind of, I feel like we've said for the whole time I've been doing this that, like, satellites are kind of, they're 5 to 10 years away from being directly usable for regulatory questions, but we're getting closer, and they're being more and more useful for more and more things. And there's like a lot of active work. NASA very actively supports connections between the health and air quality stakeholder community, the kind of the environmental groups, the states, the EPA, and researchers, and trying to, like, take questions that matter to the people actually implementing this and answering them with satellite data. So there's a lot of work in that area, and sort of continuing evolution in that area.
Dr. Limaye, would you have anything to add?
Those are great. I see a question about, would you say these new monitors are more or less effective than previous methods? From my perspective, they are way more cost effective, and they are data-wise very effective in flagging, especially areas that aren't being adequately captured by our current monitoring network for us to look further. So in some sense, it's in the eye of the beholder.
That makes sense. I had a quick follow-up for Dr. Dickens about or anyone, if you know the specifics about the satellites. I'm just curious, like, how can they even, like, what are they actually using to sense the surface? Like, I don't even know how to ask it. Like, what kind of methods are they using to do that? Because it does seem like weird because they're all the way up in space. Like, how does that work?
Yeah, it's generally, visible light, and different molecules will absorb at different wavelengths. And so you can kind of measure the absorption. And that generally gives you like we could say column measurement, being the total amount between the satellite and the Earth. But then they use things called air mass factors, and things that kind of, like for nitrogen dioxide, that's sort of the one that's probably works best from satellites. And it's partly because it tends to be in the lowest parts of the atmosphere where we breathe. Like, the most of the NO2 is near the Earth's surface. So when you see it, you can assume that you're near ground level. But there are kind of, they have things where they weight what they are seeing based on where it's normally found at different heights in the atmosphere. Or they look at it, rather than kind of looking straight down, they're looking at it from an angle and kind of, using that to get some, like, there are some ways to get profiles. And honestly, I don't completely understand how they do it either. But there are ways to get at that. There was this nice satellite that is out of commission. That's about a year ago, Calypso, that will get the species of particulate matter. So it would tell you, is it smoke, or is it, is it just a brown carbon, or what is it now? What altitude is it? But they'd give like one little narrow strip at a time. So most satellites, you're getting kind of eventually you're getting the whole country covered, the whole globe covered, but this one is giving here and here and here, but you're getting more information about each of those areas.
Oh, that's interesting. And then I guess in a similar vein, you said that they're like people say they're like 10 years away from being usable. What kind of advancements do you see being made to make this data like very usable and helpful in this issue?
Yeah, I'd say it actually it is useful in some contexts today. Like actually I know Wisconsin's Air Trends report, I think when I was there, we added in just a satellite view of like looking at, 10 years ago and current NO2. And so you can see the reduction just from that. So it is useful in some contexts. It's not useful when determining whether you're meeting a standard. And I don't know that it's ever going to be useful for that, but I think there's a lot of other questions, like how does it change from day to day? We have a brand new satellite launched, launched about a year ago, but started making routine measurements in October, and they're going to be available any day now. That's called Tempo, that takes out, it's geostationary over the US. So normally most of the satellites, air quality satellites before, were polar orbiting, meaning within 24 hours, they circle the globe. So you basically get wherever you are, you get a picture once a day, early afternoon. This is now sitting over the US, and every hour it's scanning the whole country. So we can get pictures of what does the pollution look like at 7 a.m., 8 a.m., 9 a.m., 10 a.m. So you can see how it evolves over the course of the day, spatially, under different wind conditions and various other things. It's really potentially really useful. Again, probably not directly for determining whether you're meeting a standard, but for understanding how things are evolving, what factors, what meteorological conditions lead to, bad ozone or distribution of NO2 this way or that way and other things.
Yeah, totally agree. This is where the science can inform policy. Like Angie said, it can't necessarily tell us where we're meeting a standard, but it can show us more about where we could be looking for something that we weren't able necessarily to understand with our network of regulatory monitors. Because like Angie said, across the state, if we're looking at particulate matter, for example, there's only actually 16 monitoring sites right now across the state looking at, so you just can't get all the information that you might that might help you see some more local impacts or local issues that are worth looking into. Nitrogen oxides, like that, Angie said that was a pollutant that was kind of best looked at by satellites, and explained that we only have 2 monitoring sites in the state for that. So there's a lot of opportunity for satellite data and that science to really inform policy decisions that we need to make to understand how we're going to best put our resources to exploring air quality issues more.
I was just going to add, I love these answers from Angie and Gail. And while they were talking at me, thinking about one point I wanted to make with all of you is that air quality is really a collective concern, right? We can be up in the satellite and notice that smoke is drifting from Canada with its own politicians, its own laws, its own monitors, down to Madison or Milwaukee or Chicago or New York, right? Air pollution that's in Milwaukee, ozone air pollution, part of the problem there is that Milwaukee is pretty close to Chicago. And so we need to worry about what Illinois is up to on air quality and whether they're doing their job, so to speak, right? So as much as we worry about really local impacts, we also have to be aware of our neighbors, both within the country, within the city, within the state, but also internationally, because air pollution doesn't respect any international boundary.
Or state lines, as you said.
Or state lines, yes.
That's right.
What do you think is the best way to ensure that all the different different countries and states are being taken into account, like across boundaries and stuff? Like, do you think that like we were talking earlier about the WHO and their regulatory framework, do you think that's effective? Or do you think there's a better way that we could be doing it?
I think across the states, some of what Vijay was just talking about, there is a lot of regulation. There are a lot of laws in the Clean Air Act about how to be what's called a good neighbor, right, to the states around you. There are a lot of laws in place to help with what we call transported emissions, which in Wisconsin, where I am, we're really the recipient of a lot of emissions that don't necessarily generate in Wisconsin, right? They come from a lot of states around us. And so we have a lot of law to take, that into account and to work on those issues. International boundary issues are quite a bit more difficult. And that's where you see, some of the international agreements and things like that, where, countries get together and talk about how they're going to address air quality issues, in particular climate pollution, as a set of nations. And so that's much trickier. I think it's going to take a lot of time to continue to work through.
Yeah, so actually the genesis story for my organization, Lake Michigan Area Directors Consortium, is actually exactly on this regional pollutant transport. Like, we actually were formed by the states of Wisconsin, Illinois, Indiana, and Michigan because of this transported ozone issue. And actually, it's because Wisconsin and Michigan sued Illinois and Indiana. Actually, they sued EPA over not holding Illinois and Indiana's feet to the fire over transported ozone emissions. So we actually act as a forum to allow. We now have Minnesota and Ohio in the group as well. So we act as a kind of table around which the states can meet to talk with each other over things, which has its own challenges and not always effective, but at least it's a way to kind of bring states together. And each of the regions have these, we're called multi-jurisdictional organizations. So there are organizations like that bring the states together around in the country. There's one in the Northeast, one in the Southeast, kind of central states, Western states, to talk and collaborate and work on this sort of transported issues. Which again is, challenging and, but I would also agree that dealing with international pollution is much harder. There's no, Clean Air Act regulation is very much a, federal act in the sense of like, it's a state and federal government working together, and they have roles defined by law and obligations, and that just doesn't exist in an international stage. So it's much harder.
Do you think that framework of creating like regional groups could work internationally if different countries would like get together and create a regional group that would then like what your organization does, like be that table for them to communicate around? Like, do you see that working?
I know there are some like that. There's like an Arctic Council, and there are which is a group of countries that have Arctic, parts of their countries in the Arctic that do meet to talk about issues and work on things. I'm pretty sure there are other, I don't know if there are other international organizations like that. I imagine there probably are. Gail and Vijay, do you know?
No, I don't. I think the concept could work, but often, as Angie mentioned with LADCO, her organization, it takes something, like a lawsuit or extraordinary cooperation to see something like that come together.
We're dealing with different countries. They have their own internal politics, and there's not an overarching international law that tells them they have to. Oh dear, just seeing Vijay's note. That there's not an overarching obligation that everyone has to do something. So that's a challenge.
That makes sense. I think we'll wrap it up pretty soon. Just a couple more quick questions. What do you think is the best way for businesses or industries to take on responsibilities to reduce air pollution?
Yeah, I think this is really, about regulation and the requirements that industry and businesses have to follow what's in the Clean Air Act and in federal and state law. So many industry and businesses are subject to these regulations. There are a lot of sources of air pollution that receive air permits and need to do that. And an air permit really can be kind of like a book or a guide to all of the requirements or regulations that a facility is subject to in order to comply with air quality regulations. And I think continuing to follow those laws, and some do take on voluntary actions as well. Many types of it, like the utilities, for example, have had sustainability, sort of clean energy goals. Some even before they were really required to do so. So we do see some things like voluntary actions and sustainability goals being set and hopefully met by a variety of different types of industry and utilities. Often, when a business or industry is going to take on some voluntary action, it can often be at the urging of the community around them. So, I always encourage people to kind of use your voice and use your knowledge, because it can be really powerful, especially when a group of people can get together. There, you can see some outcomes from that. We do tend to see that voluntary actions from communities asking for that.
Yeah, I don't have a lot more to add to that. I haven't really worked that much directly with industry to know that. I mean, one thing I was kind of thinking about, and I'd be curious, Gail, if to hear your thinking on this, that California and the Northeast have a lot stricter standards, and so I was kind of wondering, is that something that a business, if they wanted to do more, could they kind of look at what California is requiring and then just voluntarily say, I'm going to use lower VOC, paints or whatever,
Yeah, absolutely. There are other states who do. California actually has written, into the Clean Air Act, the ability to get kind of a waiver from the regulations to do something even more stringent. They do this especially with vehicle regulation. So some places where we might see that, there's some Tier 4 engines based on California standards. So places that need maybe generators can look to those engines that meet more stringent regulations than may be required in their own state or their own community. And they can use some of that kind of technology to just make different choices or better choices and emit less. Yeah, it's a good call, Angie. That's absolutely an option and something that we do see some industry trying to do.
That's interesting. Dr. Limaye, are you back on?
I am. Sorry, I'm on my phone.
No worries. I don't know if you heard the question. It was about businesses or industries,
I did.
like how to make them take responsibilities. Okay, would you have anything to add?
I think maybe the only other thing I'd say is that air quality and health are very much political issues. So businesses have interests in what we decide to do here in the US and elsewhere. And so just as businesses, can operate in the political space, we need to ask them to advocate for smarter air quality policy.
Makes sense. Thank you. Brianne, are there any other questions that you think we'd want to ask before we kind of call it here?
I think that's all. Thank you so much to our panelists for joining us today. They have provided us with plenty of insight on air quality issues and steps that we have taken and can take in the future. And good luck to everyone at Internationals. Talia, is there anything you'd like to say?
Yeah, thanks so much, Brianne. I just also wanted to say thank you so much to our wonderful panelists and everyone who joined today. And also Brianne and Toby, you were wonderful moderators. And before we hop off, I have two final closing remarks. Everyone should expect to see the recording of this panel in your emails in the upcoming week or so. And once you receive it, feel free to share with your coaches or your team. And then my second point, if you're an FPS participant interested in joining the student advisory group and organizing fun panels like this one, you can find information on the FPS website or contact me, Talia, at fpspi.org. So with that, our air quality panel has come to a close. Before everyone hops off, I'd love it if they could say thank you to our fantastic panelists in the chat for their time and all of the really valuable information they shared with us. But that's it. Good luck, as Rian said, to everyone competing at the FPS conference. And I hope that everyone has a great rest of their day. I'll see if April wants to add anything, but that's all for me.
No, I just added it in the chat, just thanked our speakers. I've read the research like many of the students on the panel here, and really learned a lot more. So thank you for just candidly sharing responses to our students. It's really special for them to have such experts to talk to. So thank you so much. And Dr. Limaye, we hope to get you involved in our future problem solving alumni network. So we'll be in touch on that soon.
Wonderful. I'm an FPSer for life. Thank you all.
Awesome. Thank you so much.
I just want to echo what everyone else said. Thank you so much to our panelists. This was amazing. And looks like everyone else agrees in the chat if you guys are seeing that. So thank you so much and good luck at International, everybody.
Yep, thanks. A lot of fun. Take care.
Yeah, thank
Bye-bye.
you very much.
Thank you.